Subscribe to our YouTube channel and press the bell icon to get the latest updates.
There are many ways that a patient with the coronavirus dies. Patients can develop severe pneumonia that then becomes an acute respiratory distress syndrome. So their lungs fill with fluid and they cannot breathe. Or they could develop blood clots or thrombosis in vital parts of their bodies. But a major driving force is called the cytokine storm, where the body's own immunity goes into an overdrive and starts killing healthy cells and organs. In this video, we'll take a look at how cytokine storms work and what leads to them, how the immune system is supposed to fire off, and what we're learning about how it actually does so in COVID patients. My name is Sandhya Ramesh and this is Pure Science. We've discussed in previous videos the innate and adaptive immune responses and the role of cytokines. Our bodies, when faced with a pathogen, has two kinds of sequential immune responses. The innate immune response is immediate and fires as soon as a pathogen is detected. It is non-specific, but it gives the body enough time to prepare a second wave of more personalized, specific attack on the pathogen. This is the adaptive response. Some cells produced during the immune response consume the pathogen and then relay information about it to T cells, which then trigger the adaptive response. The specific mechanism through which this is implemented during the innate response stage and these responses controlled or modulated is through the production of cytokines. Cytokines are small proteins that perform signaling between immune system cells. It is cytokines that determine how much the immune system should keep going, essentially maintaining control over the production of T cells and B cells and antibodies and other kinds of immune response cells and signaling between them. Sometimes these cytokines misfire and are produced in excess quantities, and these then end up triggering a non-stop response even after enough T cells and antibodies have been created already. These immune cells then start to attack our own bodies, leading to inflammation, acute pneumonia, and then sepsis, where the virus then spreads through the bloodstream to other organs. Since a lot of organs are covered with the ACE2 receptors, which the virus uses to enter our nasal cavity and lungs, the virus also enters into other organs, eventually causing organ failure or thrombosis, which is excessive blood clotting. This is not an uncommon phenomenon. Cytokine storms do occur with several other diseases as well, and they're especially common with diseases that are induced by viruses. Cytokine storms were the biggest cause of death during the 1918 Spanish flu pandemic that killed an estimated 50 million people as well. Inaccurate production of cytokines can also happen without a viral infection and is also linked to other mental health related conditions like major depression and Alzheimer's. Cytokines are therefore an important protein in our bodies, and they are of many kinds like interferons, interleukins, and lymphokines. And each group of cytokines mediates information between different kinds of cells that are involved in the immune response. Some of the drugs we're developing try to inhibit these cytokines. Tocilizumab, for example, is supposed to work by inhibiting the IL-6 cytokine protein, the interleukin 6. Other drugs, of course, quell the effects or symptoms of the disease, such as the glucocorticosteroid dexamethasone, which mimics cortisol and tempers inflammation. The most common way to control cytokine storms is by using steroids or immunomodulatory drugs. These are, as the name suggests, drugs that can control the immune system's reaction and intensity of the immune response. Such drugs are commonly used to treat autoimmune diseases, which are the ones where our own immune system misidentifies our own body's cells as a foreign pathogen and mounts an immune response against it. Some such autoimmune diseases include lupus and rheumatoid arthritis, the two most common ones that we hear of. There's also psoriasis, inflammatory bowel disease, type 1 diabetes, multiple sclerosis, and even celiac disease. Many drugs and steroids such as dexamethasone and even hydroxychloroquine have been used for treating autoimmune diseases, and news reports of any perceived successes with these drugs in treating COVID tend to drive up sales of these drugs, creating problems for those with autoimmune issues who need these drugs more on an everyday basis. And as the medical community has always known, and as most of us are learning in real life right now, what works for one disease might not necessarily work for another. Additionally, drugs can even cause other kinds of complications when being used to treat a different disease than what they're intended for. We're just finding out these things when it comes to treating COVID specifically. So developing drugs with the purpose of modulating immune response is proving tricky because COVID is a disease that the immune system simply doesn't seem to understand. New studies that are coming these days indicate that the immune response is all over the place among COVID positive patients. There's a story in New York Times by journalist Catherine Wu, which will be linked in the description box below. In the story, she describes this new study from last week in Nature Medicine by the Yale Immunology team led by Professor Akiko Iwasaki. Their study describes how the kind of triggers for cytokines are all messed up among people who test positive for COVID. They found that people with the most severe forms of the disease mount an immune response that is in fact putting out signals which are more efficient for killing pathogens that are not viruses but are either things like worms or bacteria or fungi, none of which need to actually attack cells for their survival. So the immune system seems to be lost in some people. It is thought that these kind of immunological missteps by the body occur because the viruses can be smart and they've developed ways to deflect the trigger for the production of interferon, which is one of the earliest cytokines produced by the immune response. The body can still feel the cells being destroyed by the virus, so it amps up the production of cytokines, which then leads to an out-of-control cascading effect. The virus is also attacking lines of communication between T cells and B cells. As we've seen, T cells are crucial to signal to B cells the kind of antibodies to produce. All of this requires modulating cytokines, and we even know which ones for the most part. However, the most important aspect here is giving immunomodulatory drugs at the right time. Timing is key. If given early, a drug that tempers immune response will prevent the development of necessary immune response. If given too late, it's simply too late. This is a big reason why development of drugs also will take a lot of time. We cannot find a magical concoction that works for everyone because everyone's body seems to react differently to the virus. Going forward, we will likely see more tailored treatments being talked about when it comes to immunomodulatory drugs and treatments for COVID.